March 2nd, 2001. The cruise ship Caledonian Star, carrying 110 passengers, is en route from the Falkland Islands to Ushuaia, Argentina. It's caught in a storm, typical for these latitudes. The waves crash mercilessly against the ship's metal hull. But what happens at 5:31 in the evening is every sailor's nightmare. Suddenly, a wave as high as a skyscraper rises, a monster wave, blocking out the sky ahead of the ship. More than 2/3 of the Earth's surface is covered by water. Yet the secrets of our oceans remain largely unexplored, the dangers lurking in the depth unknown. But the most dangerous forces may be waiting at the surface. Towering, suddenly appearing massive breakers, known as kavensmena, freak waves, rogue waves, or monster waves. They can reach up to 35 meters in height and pose an unpredictable danger to shipping. Numerous shipwrecks have been attributed to them, and for a long time, their existence was uncertain. As ships were modernized and became more stable, more witnesses survived. Today, global shipping thrives, driven by massive cruise ships carrying thousands of passengers. However, these enormous vessels, with numerous windows, are highly vulnerable to monster waves. A collision could cause immense damage and cost many lives. What causes these formidable forces, and where do they strike most often? Oldenburg, Germany. Here lives one of the few people who has faced and survived the destructive force of a monster wave. Carl Urish Lamper, long-time captain of the Caledonian Star. On February 10th, 2001, he set sail from Chile's southern tip aboard this ship for a 23-day voyage to Antarctica.
The winter of 2000 to 2001 was my first season with the Caledonian Star in Antarctica. I'd already spent every winter there from 1987 until then, so I was very familiar with the area, but the ship itself was new to me.
On board the expedition cruise, a crew of about 50 and 110 guests, mostly from the USA and Great Britain. The only German was Captain Carl Urish Lamper.
Right, let's go out smoothly. How are we looking on the starboard side?
A single ticket costs a 5-figure sum in US dollars. In return, passengers expect an unforgettable journey. Breathtakingly beautiful landscapes, snow-covered mountains, untouched glaciers, and uniquely diverse wildlife. With over 90 Antarctic expeditions, Carl Urish Lamper has made maritime history. In honor of his extraordinary career, both a bay and a glacier now bear his name.
There was still plenty of ice, but nothing unusual happened. Then we had just one final day at sea from the Falkland Islands back to Ushuaia, the very last day of the season. That's when everything changed.
We've just received the weather update.
What does it say?
There's a storm warning for our route. It's expected to hit in the next 12
The weather forecasts predicted winds of around force 7 or 8. Unpleasant, but not enough to halt the journey.
Hi, Captain. Should we change our course?
Not yet. We might have to adjust our plans, but we don't want to alarm anyone unnecessarily.
When you travel to these extreme regions, as I have for the past 25 or 26 years, wind speeds of force 7 or 8 don't cause concern. I accepted them as a given. There's no reason to be alarmed.
For the experienced crew, it's a routine crossing. As guests enjoy their dinner, the Caledonian Star leaves the harbour at New Island in the Falklands. A light breeze drifting across the water. As passengers settle in for their last night of the journey, they remain unaware of what lies in store for them.
Let's get some rest. Good night.
Good night.
A wave may seem simple, but in reality, it's one of the most complex forms in nature. Ocean waves form primarily when the wind blows over the water, transferring its energy. Ocean currents also play a role, as does the seabed near coastlines. Waves, winds, and currents continuously interact with one another. This is why a precise prediction of ocean waves remains impossible to this day. Then there is the phenomenon of the monster wave, a brief but powerful event that can unleash extreme forces within seconds before disappearing again. A monster wave is defined as one that is more than twice the height of the highest third of the surrounding waves. For a long time, the phenomenon was dismissed as mere fantasy, an exaggerated tale from sailors embellishing their adventures. Many did not survive monster waves, and those who lived to tell the tale were written off as crazy, much like those who spoke of sea monsters. For a long time, even science believed monster waves are physically impossible. Until New Year's Day, 1995. Around the Dropna oil platform, approximately 160 kilometers southwest of Norway's southern tip, a massive storm rages in the North Sea. The platform had only been in operation for a few months and was equipped with several modern instruments to measure wave heights. At midday, waves up to 12 meters high are recorded. But suddenly, just after 4 in the afternoon, the instruments register a single wave nearly 26 meters high. A towering wall of water rises in front of the platform, barely passing beneath it. This is the first monster wave ever confirmed by recorded data. Only then was it officially recognized. Immense natural events like these do indeed exist. Tokyo, Japan. One of the first researchers to observe a monster wave was German-Tunisian scientist Armin Chabchub, but not in the open sea, rather in the controlled environment of a laboratory.
I've always found waves fascinating. Even as a child, I enjoyed spending time at the beach, watching the waves break. And then I realized that you can describe them beautifully using mathematics.
Today, Armin Chabchub works at the Okinawa Institute of Science and Technology and regularly visits Japan's capital for research purposes.
When you study, you encounter more equations. And then you realize that the mathematics you learn, the equations you derive, can describe wave movements. And that, of course, is fascinating, to explain nature using mathematical formulas.
In one of the world's most advanced wave tanks, Amin Chubchub studies how monster waves form. Working alongside his Japanese colleague, Takuji Waseda, he generates them under controlled laboratory conditions. With a length of approximately 50 meters and a depth of up to 7 meters, the University of Tokyo's wave tank is among the largest in the world. Inside, the research team can generate waves. What measures just a few centimeters in the lab corresponds to waves many meters high in nature. Only here can monster waves be deliberately created and studied in detail. The lab also contains model ships to test the impact on various common ship structures, simulating on a small scale what happens in the vast, unpredictable ocean.
It's not just about understanding monster waves. Of course, that is part of our work and research, but these findings have much broader applications for improving wave prediction. That's crucial for maritime navigation and safety at sea. And of course, as a researcher, it is also a lot of fun.
In the tank, scientists can replicate waves of a stormy sea, just as they form in the ocean under extreme storm conditions. Like the storm on the night of March 2nd, 2001, in the South Atlantic. For the Caledonian Star, conditions worsen as expected. Since midnight, the wind has steadily strengthened. By 5 in the morning, the first passengers wake as the ship sways noticeably. On the bridge, alert levels are raised. Contrary to forecasts of strong winds, the ship is now caught in a hurricane-force storm. The anemometer records speeds exceeding 30 meters per second. Over 100 kilometers per hour. Captain Carl Urish Lamper orders the ship to be steered onto a safety course.
Helm, adjust to 270 degrees. Steady as she goes.
The height of the bridge, meaning the eye level on this ship, was around 10 meters. When waves passed by on one side, they rose slightly above us. You could see at once. They were enormous, truly impressive.
But the wind strengthens further. Captain Carl Urish Lamper orders the dining hall and outer decks to be closed.
Ladies and gentlemen, this is Captain Lamper. We are encountering stronger winds and heavier seas than anticipated. Your safety is our priority. Please make sure you store your suitcases in the shelves and cupboards provided in your cabins. Please remain in your cabins and avoid unnecessary trips around the ship. Thank you for your cooperation.
The passengers find the storm an immense strain. But for the experienced crew in the engine room, it is barely a concern. They are well accustomed to rough seas. The ship's engines, originally built for a fishing trawler, run smoothly. In the middle of the route between the Falkland Islands and Ushuaia, Argentina's southernmost city, the ship battles through the waves. Trapped in the Argentine Sea at 63 degrees west longitude, the Caledonian Star now moves against the wind at walking speed. Captain Lamper records in his logbook hurricane-force winds of the highest intensity from the west-northwest, very high seas, and heavy sea conditions with a gale warning.
It's certainly a very unpleasant situation, and for someone who's never experienced it before, it can feel truly threatening, no question about it. In that moment, I was glad to be on this ship because I knew that a vessel originally built as a fishing trawler for these waters could withstand something like this.
At this point, the Caledonian Star is in the middle of the South Atlantic. In certain regions, like this one, extreme monster waves occur more frequently. These are areas where waves collide with powerful ocean currents or eddies. Examples include the southern tip of South America, the east coast of South Africa, and the waters off Japan. However, storm-prone areas such as the legendary Bermuda Triangle, parts of the North Sea, the North Atlantic, and the North Pacific are also known for them. They are particularly dangerous off the coast of Japan, where the infamous Kuroshio current flows. Heading to a place unlike any other in the world, around 360 kilometers from Japan's capital, Tokyo, a volcano rises from the sea, encircled by the Kuroshio current, the island of Agashima. At just under 6 square kilometers, it is Japan's smallest and most remote municipality. Agashima is accessible only by ferry or helicopter, but severe storms often isolate the island for days, especially from late autumn to spring. Exposed to the open sea, its weather shifts every half hour. The island is a known hotspot for powerful storms and towering waves. It is no surprise that the few residents speak of alarming giant waves. The waters surrounding the island are known as the Devil's Sea, often compared to the infamous Bermuda Triangle. Local fishermen are well aware of the danger of sudden monster waves. They call them Sankakunami.
Sankakunami forms here when two currents collide. There's such a spot just ahead. One current flows from here, the other from there. Where they meet, these waves can form. That's where it's dangerous.
Powerful ocean currents like the Kuroshio current promote monster waves. When waves move against the current, they can become trapped. The trapped waves concentrate and amplify, allowing a monster wave to form. When ocean currents collide, as they do off Agashima, the chances of monster waves increase.
You can imagine two balls colliding. The one on top gets pushed even higher. It's the same with waves. When you have an opposing current, the waves start to focus, grow larger, and monster waves emerge.
Even near the coast, sudden giant waves, likely monster waves, form off Agashima. They strike the volcanic island unimpeded, as its steep underwater slope offers no shallow coastal areas to break the waves.
When you go rock fishing, a big wave rolls in every few hours. It's dangerous, so you have to be careful. Many people have been swept away by these waves.
Fisherman Seishi Hiroa has experienced exactly this himself.
The weather was just like this, cloudy and windy. Normally I fish lower down, but because of the strong wind, I went to a higher spot. Then suddenly a Sankakunami hit me, and my fishing rod, my basket, everything was washed away. I was dragged 7 or 8 meters. It hit so fast, I have no idea how big the wave was. Out on the ocean, the average waves were around 1.5 meters. I saw whitecaps and expected some waves, but I never imagined one that big. After that, I stopped going there as often. Many people from the island have been taken by the sea. That's why I became more cautious.
The old harbour where Seishi Hiroa's accident occurred has been closed, with access roads now collapsed. That spot is no longer dangerous, but the rough sea remains unpredictable. Not just in Agashima, the impact of a monster wave is almost always fatal. In December 1978, one of the largest search operations in maritime history begins. The superfreighter Munchin has vanished after a severe storm in the Atlantic. All 28 crew members are missing. Only a lifeboat is recovered from the Munchin, one of the largest and most modern ships of its time. It turns out that an immense force tore it from its mooring more than 20 meters above the waterline. In the autumn of 2002, the oil tanker Prestige sinks, possibly due to a monster wave, causing an environmental disaster along the Spanish and French coasts. In 2010, 2 passengers lose their lives aboard the cruise ship Louis Majesty when a giant wave strikes in otherwise calm seas.
We heard a loud noise at the same time the wave arrived. Then we left our room and saw there was water everywhere. Our entire floor was flooded.
There was a lot of damage. Many people were injured, though most wounds were superficial. They called for all available doctors. I think we narrowly avoided a major disaster.
Just before Christmas 2023, the cruise ship MS Maud loses power. A massive wave in the North Sea shatters the windows on the bridge, leaving the ship unable to navigate. Only sheer luck prevents a major disaster. These examples show that mysterious giant waves pose a real threat to commercial shipping. However, official data is scarce, as the industry remains tight-lipped about such risks. A recent study examined incidents involving monster waves from 2011 to 2018. During this period, 24 ships went missing and 50 ships sustained damage. The events led to nearly 200 injuries and almost 400 fatalities. It is still unclear how climate change affects the occurrence of monster waves. What is certain, however, is that storms are becoming more frequent and intense, increasing the likelihood of exceptionally large monster waves. For this reason, researchers are trying to uncover the secrets of monster waves. Using wave tanks, they recreate rough seas to study how these dangerous giant waves form.
Now, the wave generator first produces short waves, followed by longer ones. What happens next is simple. The longer waves travel faster than the shorter ones. Here you can clearly see the short waves that have already formed, moving slowly. Meanwhile, the longer waves are being generated. You can then observe how they gradually merge. First one merging, then another, creating even larger waves. Finally, the waves reach their maximum overlap, leading to the breaking of the wave.
The formation of monster waves is like a race spanning hundreds of kilometers. Long waves travel faster than short ones. The faster waves gradually swallow the slower ones, growing larger until, suddenly, a monster wave rises. But when waves from different directions collide, they can combine dangerously, a phenomenon known in maritime terms as a cross-sea. Such a giant wave can reach up to 35 meters high. In this wave tank, a wave of this height is generated in the same way, but on a smaller scale. According to statistical calculations, 1 in 10,000 waves would develop into a monster wave in this way. From the perspective of ship captains, monster waves seem to emerge out of nowhere on the open sea. However, they often travel far before reaching full force.
These waves travel thousands of kilometers before meeting younger waves. The fascinating part is that this process is nearly impossible to predict. Then, suddenly, a monster wave appears, a serious danger to the shipping industry.
On March 2nd, 2001, the Caledonian Star sails straight into danger. Wind speeds of over 200 kilometers per hour whip across the ocean. The ship pitches and rolls through the South Atlantic.
At that moment, I believe the most important thing was to have crew members stationed in the hallways and passenger cabins at all times. That way, if any passenger felt abandoned, anxious or alone, they would immediately see a reassuring presence. Someone ready to assist, offer comfort, or simply let them know they were not facing this situation on their own. To let them know they were not alone, that was important to me, and it seemed like the right approach.
At 5:30 in the evening on the bridge, First Officer Goran Persson, a helmsman, and a lookout. Suddenly, a foaming colossus rises from the water, estimated to be 25 meters high, completely blocking the horizon. Goran Persson reacts immediately.
He adjusted the ship's course slightly so it would face the wave head-on, a crucial decision that prevented the vessel from taking a dangerous hit. I have to say, at that moment, he acted with absolute precision, making the split-second choice that may well have saved the ship.
The Caledonian Star, just 90 meters long, bravely climbs the massive wave, crests the top, and plunges into a vast, ominous dip, where a second killer wave rises. This one is also about 30 meters high. The ship barely manages to climb this second wave, but then a third monster approaches, over 30 meters high, a wall of water as tall as a 10-story building.
It felt like the ship had been struck by a giant hammer. A deafening impact. The whole vessel vibrated, of course. You have to picture it. Hundreds of tons of water crashing down on a relatively small ship. My first thought was, we are already going under. This is it.
How can modern ships withstand such forces? Armin Chabchub and his colleagues are trying to find out. A ship model with a standard hull, as used in commercial shipping, is perfectly balanced, placed in the wave tank, and then exposed to an artificially generated monster wave.
Is the GoPro running?
Yeah,
The goal? The researchers aim to show how large modern ships can withstand even extraordinary giant waves. If a ship approaches a monster wave head-on, the sudden surge of water has little effect, as the bow effectively cuts through the wave.
Perfect wave.
But then, our scientists alter the angle of impact.
Ready? Ready. Okay, start.
At a 45-degree angle, the ship's hull meets the giant wave. Water enters, a massive problem on the open sea, as it can destroy the ship's electronics and leave it unable to maneuver. It becomes especially dangerous when the wave strikes the ship from the side. At that point, it has little chance and capsizes.
In solchen bestimmten Seegängen.
In certain sea conditions, you have to steer into the waves to stay relatively safe. But changing direction can take nearly 20 minutes. It is not like in the lab here, where you can turn the ship quickly. It takes time. And sometimes there is simply no time to react.
Auch keine Zeit zu reagieren.
The crew of the Caledonian Star reacted correctly. The ship faced the wave head-on and plunged through it like a submarine. But only emergency power remains. In the engine room, the crew quickly assesses the situation. The people on board are in a life-threatening situation.
I knew that was a monster wave, but I was fully aware that we were incredibly lucky to have survived it. Because if, hypothetically, we had lost engine power or control of the ship, that could have been the end of our journey.
The emergency situation unfolds instantly. The captain grabs an emergency buoy and throws it overboard. Upon contact with salt water, it automatically sends a mayday signal. But help is hundreds of nautical miles away.
We'll get through this! Steady hands! Hi, Captain!
And Goran, even though he's a Viking type, stood there shivering from the cold behind the wheel. The windows were open. The wind was unbelievably strong. He was soaking wet and shivering from the cold. I thought to myself, we are doing everything necessary, but I have little hope. In these seas, no one could have helped us, neither from the air nor from the water.
The only chance lies in the hands of the crew. Now it's all about saving the ship. Every available material on board is gathered to seal the shattered windows on the bridge. If water enters uncontrollably, the ship risks sinking.
Looking back, it's almost a miracle that there was no panic. Honestly, there was none.
The passengers are instructed by the crew to abandon ship if necessary.
It was incredible how well the passengers followed instructions and how the crew reacted. And maybe in some way, the impact itself played a role. Because, of course, crew members were standing there and you could see the fear on their faces.
Most of the electrical equipment on the bridge has failed. The ship is practically deaf and blind. Fortunately, the engines are still running. And Carl Urish Lamper has learned to navigate using the stars and the sky. A magnetic compass helps keep the course. Miraculously, the ship has survived the deadly monster wave. In Japan, they are called triangular waves, sankaku nami. These extremely steep waves often break or are on the verge of breaking, posing a deadly threat to ships. The most famous depiction of such a wave comes from the 19th century. Katsushika Hokusai's The Great Wave off Kanagawa. Perhaps the first visual representation of a monster wave. The fear of the sea's destructive forces is deeply embedded in Japanese consciousness. The residents of Agashima Island approach the coast with the utmost caution, aware that any trip to the shore could be their last. Alisa Yamada is a salt producer. Every morning, she gathers salt from the sea. The fear of sankaku nami is always on her mind.
The sea here is terrifying. Now that winter is approaching, you have to stay alert. There have been so many typhoons lately. The swell is what scares me the most. That's why I stand here, constantly watching the sea. The sea is like a living creature. It's terrifying. I've never counted, but about every 10 years, an accident at sea happens, and it frightens me. Our island has so few people that when someone who was practically part of the landscape suddenly vanishes, the feeling that they were taken from us stays vivid in our memory. Such accidents here are always caused by the sea. All of us on the island fear it.
It's a fear that also troubles many in the maritime industry. The central question is this: is it even possible to fully protect a ship from the forces of monster waves? The shipping industry avoids commenting on this issue. The risk of alarming potential customers is too great. A billion-dollar market could be harmed by negative headlines. A case like that of the MS Maud is currently being litigated. Who is to blame when something goes wrong?
These floating hotels, as they're built today, are not meant for waters like these. I would say they're not designed to withstand such waves.
Most cruise ships have beautiful panoramic views so you can enjoy the sea. I wouldn't stand in front of those windows.
The windows are the problem. They cannot be built to withstand massive water impact. A problem that this ship does not face. The corvette Oldenburg, one of the most robust ships ever built. Marco Bork from the Bundeswehr Procurement Office is an expert in naval equipment. He knows how modern ships must be built and is one of the few willing to speak on camera about it. The German Navy operates numerous ships across the world's oceans. As they are built for potential wartime scenarios, their technology must meet the highest standards.
A key difference between a naval ship and a commercial vessel is that if I come under fire, I not only need to defend myself, but also withstand potential damage. The ship must be able to take a hit and remain operational, so I can continue my mission.
The Oldenburg weighs around 1,800 tons, accommodates a crew of 61, and is specially reinforced to withstand attacks. Its reinforced steel structure, built without windows, offers few weak points. But even it would not survive a monster wave over 30 meters high. Modern ships like the Oldenburg are built to international standards, which assume a maximum wave height of 15 meters.
It may be true that much larger waves have existed in the past, but designing ships to withstand them would make shipbuilding vastly more expensive, complex, and difficult to achieve. That's one reason. The other is perhaps we don't even need to.
Even modern warships like this one steer clear of known monster wave hotspots. No ship is built to withstand extreme monster waves, so the primary strategy is to avoid the risk.
One should always approach nature with humility and respect. It would be arrogant to believe that human technology and expertise can overpower it. Time and again, nature has proven us wrong.
Even armored warships offer no protection against monster waves. To this day, there is no design that can withstand these natural forces.
I think for shipping industry, the tendency is not to design a ship to withhold these strong forces, but to avoid these dangerous seas. We can estimate which area will have large occurrence probability of rogue waves. If we can forecast that, ship can avoid this area. I think this is more realistic for shipping industry.
Nevertheless, prediction remains the biggest challenge. Monster waves always appear suddenly, seemingly out of nowhere, and they are far more common than previously thought. All we can do is calculate probabilities. Paul Harmson and his colleagues from the Federal Maritime and Hydrographic Agency, BSH, know this well. Today, they are landing on the Fino 1 research platform, 45 kilometers north of the East Frisian coast, surrounded by Germany's offshore wind farms. The engineers are like guardians of the North and Baltic Seas, at least in regions belonging to Germany. For them, measuring weather and waves is part of their daily work. Since 2003, continuous data collection at the research platform has been undertaken to support the development of wind energy facilities in the region. Of particular interest are the extreme weather conditions that can occur here, including waves. A wave buoy measures height of the waves around the platform, while a modern radar system tracks approaching waves. And a current meter at the base of the platform records associated ocean currents. What researchers are observing is alarming. The walkway beneath the research platform is 15 meters above the waterline, higher than the tallest waves normally expected in this part of the North Sea.
Right here, where I'm standing, the platform was struck by a wave in 2006 with such force that the railings were completely bent and some of the floor grates were torn away. Our measuring chain was partially broken and the damage was significant.
A wave of this height should statistically occur only once every 100 years. But on that night, there were several comparable waves. Damage like this should therefore not happen.
That requires an immense amount of force. But when waves strike the platform, they have the power to cause this kind of damage. And really, this should not have happened, considering how high we are above the water.
3 years later, a surveillance camera captures the impact of another monster wave, equally as high. These events continue to take place.
Standing here now, it's hard to imagine waves reaching high enough to strike this platform. But in reality, our experience shows that they do, and that is why this research is so important.
These observations are particularly important for the surrounding offshore industry. They mean that wind farms and other structures in the ocean must be designed to endure such sea conditions to ensure safety. But above all, they show that when research closely examines giant waves, including monster waves, they seem far more common than previously assumed. Long-term studies in Tokyo's wave laboratory suggest the same. Monster waves occur far more frequently than previously thought. There must be a theory to explain why these waves happen so often.
Try it again? Yes, we try again. Okay, yeah.
Wind energy is transferred to the waves, causing them to grow in size and speed. Individual waves form into groups, shown here in green, with these wave groups consisting of up to 20 waves. Energy within the wave group builds up and can suddenly transfer to a single wave, transforming it into a monster wave before it collapses again. It's impossible to predict which wave this will happen to. This mechanism for monster wave formation can also be simulated in the lab.
These monster waves form locally when one wave absorbs the energy from its neighbors, suddenly rising out of nowhere, more or less. And then, just as quickly, they vanish again.
A monster wave forming in this way is 10 times more likely to occur.
It is almost like magic. You do not expect it, yet you can see it happening clearly. In the wave tank, in the ocean, we now know that this is real, that it can happen there too. Oh yes, you can see it clearly here. And the same phenomena occur in the ocean too.
According to this, 1 in every 1,000 waves becomes a monster wave. No matter where you look in the ocean, a monster wave will occur there within 8 hours. But only in extremely rough seas do they become large enough to threaten ships. Even through the night, the Caledonian Star rolls dangerously in the South Atlantic waves. The clocks, along with nearly all of the ship's electrical systems, stopped at 5:31, the moment the monster wave struck. Fortunately, the engines continue running without issue, and the ship remains maneuverable. On the ship's bridge, a handheld GPS device, typically used for inflatable boat excursions, now supports navigation. The storm finally subsides around 4 in the morning, allowing Captain Lamper to set course for the ship's destination.
During that time, we were so tense, so full of adrenaline, that you don't even realize it. Everything happens almost automatically, just as you were trained to do.
The tension only eases much later, when the ship finally reaches its destination safely.
When we docked in Ushuaia, when it was finally over, that was when I had a weak moment. I broke down in tears.
Just a few days later, Captain Lamper sets sail again with the Caledonian Star. He continues to travel to Antarctica many more times, but never encounters another monster wave like the one on March 2nd, 2001. Monster waves are a real danger at sea. That much is clear. Thanks to scientific research, we now have a better understanding of how they form, how often they occur, and where they pose the greatest risks. In severe storms, they may be rare, but they are indeed a very real threat.
We are now gathering more and more data, especially with artificial intelligence. Over the next 10 years, there will certainly be significant advancements, making this field all the more exciting.
There is still no precise way to predict when and where a monster wave will form. However, such predictions are urgently needed to prevent future maritime disasters.
I think rogue waves, the word is known, but I don't think the shipping industry is considering that in their like selection of the courses or like when to depart and things like that.
Throughout history, people have always lost when they were too optimistic and underestimated nature. No matter how advanced technology becomes, there will always be exceptions. Ships thought to be unsinkable that suffer enormous damage, proving nature's unpredictability.
At sea, there is no absolute safety. The ocean and its raw power remain a formidable challenge. Fascinating, dangerous, and never fully controllable.